Hello, AB Calculus class. This is 2007 question number 4. Notice it says the second attempt. This is the first problem I've had to do a second attempt for. I got all the way to the end and realized I had made a small mistake in the beginning and it ruined everything. So here we are. Alright, so part A and part B. There's only two parts, which means they're going to be difficult. And they are. So the first one says, find the time at which the particle is furthest left and furthest right. Now, some quick items to make. This is x of t, which is the position function. And if you have the velocity function, when the velocity is greater than 0, remember a particle is moving to the right. And when the velocity is less than 0, the particle is moving to the left. And when the velocity is 0, a particle is what we say is at rest. So we have a particle that's moving left and right and left, and we want to know when is it furthest left, and they could have asked when is it furthest right. But a particle is either furthest left or furthest right at the endpoints or the critical points. And the critical points are where the derivative, the velocity, is equal to 0. So remember, if velocity is negative, it's moving to the left, and then velocity is 0, it's at rest. And then it's moving to the right, and then it rests, and then moving to the left. So we're going to go ahead and find out when is velocity equal to 0, and we're going to test the endpoints and the critical points to see which position is furthest left and furthest right. So, in order to do this, we need to first find out when is the particle at rest, because those are going to be our critical points. So again, at the end of the day, I want to test the particle's position at time equals 0 and 2 pi. Those are the endpoints, and then some critical points. And we're going to add those critical points in here in just a bit. Alright, we have the position function. We need the velocity function. Remember how things go. You have position, its derivative velocity, its derivative acceleration. So the derivative of the position function is the velocity function, and here it's required that we do the product rule. So we have the product rule, which is the first piece, e to the negative t, times the derivative of the second piece. The derivative of sine is cosine. And this is where I messed up. The first time through I said the derivative of sine was negative cosine, and I got 10 minutes into the problem before I realized I messed up. So first piece times derivative of the second piece plus the second piece sine times the derivative of the first. And the derivative of e to the u is e to the u times chain. Now I'm going to look at both of these, and I'm going to GCF out an e to the negative t. So my velocity can be rewritten as e to the negative t, and that leaves me with a cosine and a sine. But I forgot, if I took out the e to the negative t, I still have this negative here, so I'm going to put the negative right here, make it a minus sine t. Okay, so that's my velocity. I want to know when is it equal to 0. Well, let's go ahead and set each piece equal to 0. So if I set this piece equal to 0, when is e equal to 0? And of course, you remember, when's e going to equal 0? E is never going to be 0. It's always going to be positive. E to the x is positive. E to the negative x is positive. E to the negative x to the third plus, it's always positive. If I threw a negative in front, now it's always negative. So this is always positive, so it's never going to be 0. So when is that 0? Nope. And now we need to set our second factor equal to 0. We're going to set this equal to 0. And if you set cosine t minus sine t equal to 0, you can add one of them to the other side, and you get, when will cosine t equal sine t? Okay. Now, when you're dealing with sines and cosines, and you want them to be equal, the first place you can look is the quadrant angles. 0, pi over 2, pi, and 3 pi over 2. But you will notice, remember, cosine's the x, sine's in the y. So cosine of 0 is 1, sine of 0 is 0. The x and the y's, the sines and the cosines are never the same. So it's not one of the quadrant angles. So if it's not a quadrant angle, it's got to be from one of the triangles. And our two different triangles that they make us use on the AP exam, we have the pi over 6, pi over 3 triangle, which is 1, 2, radical 3. And we have our 45, 45, 90 triangle, our pi over 4 triangle, which is 1, 1, radical 2. Remember, sine is opposite over hypotenuse. So let's look at pi over 6. If it was sine, sine would be 1 over 2, opposite over hypotenuse, and cosine would be the square root of 3 over 2. Those aren't equal. If you use pi over 6, sine is square root of 3 over 2, and cosine is 1 over 2. Not the same. But look at pi over 4. If you're doing sine, 1 over the square root of 2, and if you're doing cosine, 1 over the square root of 2. So you'll notice at a pi over 4, both sine and cosine are equal. But it's not enough that they are equal, they have to also have the same signs. So we're going to take a moment, and we're going to look at all the different pi over 4s that we have. So, our pi over 4s in our first quadrant is pi over 4. Second quadrant we have 3 pi over 4. Here we have 5 pi over 4. And here's 7 pi over 4. My daughter is in here, one of them watching me. And so I'm sure she's a little confused. Remember, this is the stuff from Miss Thompson's class. So this is your trig stuff last year. And we're going to use all students take calculus to help us figure this out. In the first quadrant, all of them are positive. Well, if they're all positive, if cosine and sine are both positive, they will be equal to each other. They'll both be positive 1 over square root of 2. Sine, only sine is positive, cosine is negative. So one would be positive, one would be negative, not equal. Nope. Here, only tangent is positive, therefore all the other ones are negative. Sine and cosine are negative, so they would both be negative, therefore they would both be equal. And here cosine's positive, sine's negative, so nope. So the places where velocity is equal to 0 is pi over 4 and 5 pi over 4. And what's going to happen is we're going to take all these different times for our endpoints and our critical points, we're going to plug it back into the position function, and we're going to see where is the particle at. And the one that is furthest to the left will be the one that's the smallest number. Now, it might seem like this problem is going to be really difficult, but it's going to be much, much easier than you expect. I'm just kidding. It's going to be horrible. Okay, so x of t equals e to the negative t sine t. So the first thing we're going to plug in is 0. So if I plug in a 0, sine of 0 is 0. So sine of 0 is 0, anything times 0 is 0. So at 0 we get 0. Now let's try pi over 2 pi. And we have the same issue. If this is 0 and pi over 2 and pi and 3 pi over 2, this is back to 2 pi. So if sine, remember sine is the y coordinate, if sine of 0 is 0, sine of 2 pi is also 0. So 0 times anything is 0 again. So now we just need to try pi over 4 and 5 pi over 4. So we're going to plug in pi over 4. And I get e to the negative pi over 4 times sine of pi over 4. Now, while I don't know what this is at all, no idea, I do know it's sine of pi over 4. It is 1 over the square root of 2, or the square root of 2 times square root of 2. So here we get the square root of 2 over 2 times e to the negative pi over 4. I'm just going to leave it. I have no clue what that equals. And now I'm going to try the last one, which is 5 pi over 4. And something interesting happens when I go to use 5 pi over 4. When I go to use 5 pi over 4, because it's in this quadrant, sine is going to be negative. So instead of the square root of 2 over 2, it's going to be a negative square root of 2 over 2 times this. Now, how is this going to be the most important thing in the whole problem? Well, we want to find out which of these values is the lowest. Now remember, e to any power is a positive. So let's look. The first answer is 0. Next answer is 0. The next one is a positive times a positive, which means this answer is positive. And my last one is a negative times a positive, which means this one is negative. So even though I don't know what that number actually means, it's the only negative answer. Therefore, this is the furthest to the left the particle reaches. So at time equals 5 pi over 4, it is furthest left at the position, let's just say the position is negative square root of 2 over 2 e to the negative 5 pi over 4. And while that is a horrible, ugly answer, it is the answer that they want, and that is part A. All right. Now we're going to go look at part B. For part B, they want us to find the value of a, that is the solution to a times x double prime t plus x prime t plus x of t equals 0. And while this problem is horrible, they offer a lot of points for steps along the way. Now, first of all, x prime t, instead of calling this v of t, which is correct, it has another name. The derivative can also be called just x prime t. We're going to use x prime t so that it matches up. So now notice we have an a. We already have the x prime t and the x of t. The only thing we're missing is x double prime t, so we're missing the derivative. So we're going to take the derivative here. So we're going to find the second derivative, and we're going to have to use the product rule. So product rule, first piece, e to the negative t times the derivative of the second piece. The derivative of the second piece, the derivative of cosine is negative sine, and the derivative of sine is cosine. It's already negative, so it stays there. So that's first piece, derivative of the second, plus the second piece. The second piece is cosine t minus sine t, times the derivative of the second piece. The derivative of e to the u is e to the u times chain. Now, instead of distributing out these e to the t, negative t's, I'm just going to GCF them out. So I'm going to GCF out an e to the negative t, and that's going to leave in my first piece negative sine t minus cosine t, and this negative is going to go in front of this one. Now I'm going to distribute it. And if I distribute the negative, I can combine like terms. So you'll see now we have in here negative sine t minus cosine t minus cosine t plus sine t. And these two sine t's cancel out. And this is now negative 2 cosine t. I'm checking it because that feels wrong. It is correct. I've done it. I'm brilliant. All right, so negative 1 and negative 1 is negative 2. So the second derivative, if it's not off the chart, is e to the negative t. And then we have this negative 2 cosine t. So I'm going to put a negative 2 cosine t. All right, so we're going to take the second derivative, the first derivative, and the original equation and plug them all into here. So we have a times x double prime t, which is right here, negative 2 e to the negative t. I don't need parentheses here, so times negative 2 e to the negative t cosine of t, plus x prime t, which is right here, e to the negative t parentheses cosine t minus the sine t, and then plus my x of t, my original way over here, which is e to the negative t sine t, and we want to know when does this equal 0. Now, something you will notice looking at each piece has the e's that can be GCF'd out. So we want to know when this will equal 0. I'm going to give myself some more space here. So I'm going to go ahead and GCF out these e's. Actually, let me distribute this to both first. I'm going to distribute this. Actually, I don't think that helps anything. Let's just GCF out. No, we're going to do it. We're going to distribute. If I distribute, I have a good feeling something's going to happen. Yes, it will. Look at this. I'm going to put this together. So negative 2a e to the negative t cosine t. You'll see what I mean by good. So if I distribute this, and then the last piece we drop, look at these two pieces. By the way, this is a horrible question to remind you. A negative one of these and a positive one of these cancel. So you're just left with negative a e to the negative t cosine t plus e to the negative t cosine t. And notice they both have an e to the negative t cosine t that you can GCF out. And if you GCF it out, you're left with negative 2a plus 1. And if we want to know when this will equal 0, we just set this piece equal to 0. And if you set negative 2a plus 1 equal to 0, you'll subtract 1 divided by negative 2, and you'll get A equals 1/2 when we check the work. A is 1/2, that is victory. It is a horrible question. Sometimes on the AP exam you just do some things, you get as many points as you can, and then you run away. So I understand if you're running away. Stay safe. Bye.